Welcome everyone to more live Linux development. Today USB drivers. And for that, because as you know, I like my hardware working, in this case Apple Xserve, I'm surprised there is a driver missing, a tiny one, but nonetheless. So this is Apple Xserve-frontpanel. So someone has written at least some user space driver. Should have. It is open. There it is. To my surprise, not only that is user space, I said this already the previous live stream. And to my surprise, so of course it's super simple, right? What are we talking? We're talking about controlling the LEDs. So this is the Intel Xserve, that is a G5 Xserve. And yes, of course, the hard HD tray should be in there. So we're talking about this blinking light, so it shows the CPU load and stuff. And this works on the G5 cube because Benjamin Herrenschmidt has written the driver. Super crazy I2S for sound attached audio field view meter. DMAing this with highest performance, crazy stuff. But so this one, the Apple changed this because this is direct Mac I/O attached or whatnot. So that is USB attached and that's missing a driver. So let's take this as an example. Maybe if this goes halfway decent, and welcome everyone, we can make a director's cut for the more YouTube channel. So this stuff is super simple, but it will probably require hours of kernel running, right? So this is just 32-bit data, and I proof of concept tested that. Even proof of concept testing took over 1 hour. And so to my surprise, this stuff is not even for Linux, right? Like I wanted to build this, didn't even build. Turns out that is for Mac OS. Craziest thing, I didn't even pay close enough attention. So someone has reverse engineered this 32 bytes, which just direct 16 bytes. Half of that is, so half is unused and the other half is just directly the LED brightness, like how you would do. Probably half unused because maybe quad core, maybe more LEDs, but maybe also 32 bytes, a super tiny size for USB, so why send less than 32 bytes? And so this stuff, I hacked this, or I couldn't even get this to work, so it took 1 hour of pre-testing this. So this user space stuff, there's something a little bit cursed going on also, like this most simple hardware, and then of course it's something cursed. Meaning this didn't configure the interface somehow. So I got this to work, like this stuff I did not get to work, but from our hexacode scanner reverse engineering stuff, I could make this work via libusb with Lua code. So let's convert basically 16 lines of Lua code that theoretically would work of sending that to Linux kernel. So how do we do? It took even like half of the preparation, like hey, already 90 minutes preparation. Half of this was actually figuring out what precisely I want to use for that. Even that was surprisingly convoluted. But long story short, already writing such a simple USB driver in the Linux kernel API stuff is surprisingly complex and annoying. Much more complex and annoying that I would want. So when we finally get to do our microkernel, hopefully sooner than later, because in my opinion this should not be more than 16 lines of code, basically, more or less, like okay, maybe 32 lines, but it will be more like 1,000 lines, especially it will be more like 500 lines or so of USB code, or like with function prototypes and stuff, and then another 500-ish lines of we will copy the Apple Benjamin Herrenschmidt of IBM's Apple PowerPC, sorry, not Apple, IBM's PowerPC Linux development fame, because probably that's maybe the only other CPU load determining code in the Linux kernel. So of course we will use it. So to develop a new kernel, good artist steal, what was it? Copy, steal, good artist. Oh, what was it? Steve Jobs, good artists, copy, steal. Good artist, copy, great artist, steal. So of course, the APIs are so annoying. Of course, you just copy a driver. Yeah, so this will be, so what we will copy, because I tried already like yesterday for like 15 minutes, it's like, dude, it's, so yeah, in Lua, I just switched on the G5. I tested this morning, a G5 Xserve, Intel Xeon. Also, shall I subscribe? Maybe we up CPU upgrades. This is somewhat a mid-range config. Like maybe we should actually DIY aftermarket some faster Xeon CPUs in there. Like maybe we get them now for 16 euro a pop. So yeah, this will be annoying. So I would also argue APIs. So for our microkernel, this is also like maybe a microkernel can be as fast as a shitty monolithic kernel, because like if all your API sucks and you write like hundreds lines of code of just sending 32 bytes, like if you make more amazing APIs, also multi-server microkernel, like maybe it's same performance, just more readable and maintainable. So as we are great artists, we just steal. I tried already to steal two other things that was like basically Linux kernel APIs, even stealing is annoying. So drivers, USB, skeleton. So we copy here, let's see, do they build this? Skeleton, maybe not. Okay, let's copy. So what I previously tried, to steal this Apple display driver, but because this is interrupt driven and whatnot and stuff, like even Apple display stuff, it's only 340-ish lines of code, but it's not the best fit. So we will not, so basically I deleted what I previously have stolen already, and let's copy this skeleton driver basically. And it's crazy, I spent 10 minutes or 15 just clicking in the web view, in the Linux kernel Git view. I just clicked for 50 minutes all drivers, like this doesn't fit like this. You only want to send 32 byte in one bulk USB request broker packet, and like even that, like this driver doesn't match, that doesn't match, that also doesn't match, like 50 minutes driver, like I spared you that. Command line that nobody knows is extremely useful. I have no idea. Probably most people don't know most of the, do you know SED, do you know TR, sort, unique, like basic shell scripting. What is a microkernel? A microkernel is where most of the drivers are not in the kernel, like Minix or QNX. Not Mac OS a little bit, Windows are also not really. But QNX and Minix, in the Linux kernel, everything is in the kernel. So like our LED driver will crash the kernel easily, and so which I theoretically prefer microkernel. So we urgently, like now that we have our T2 Linux and otherwise amazing shape, we really urgently finally need to do amazing kernel, because I want to write drivers in 30 lines of code and not 500 or 1,000. So 500 lines of code or so will just be background threads monitoring the CPU load, right? When we get this working soon. What about apropos command? You can use search things. Okay, amazing. So copy the skeleton, USB skeleton, here to xserve-frontpanel.c. Override. This is a tree. You know what? Okay, why? How is this a tree where because I patched this in. Okay, fair enough. Okay, I started this last night already, but this was not yet functional anyway. I just like 10 minutes copy pasted stuff together, and that was too shitty. So this from now on will be the Apple Xserve. Actually, you know what? We could Apple Xserve USB front panel driver. Based on that, copyright us, and where we have stolen it from, Greg Kroh-Hartmann's skeleton example, that indeed was the best example I could find. So then I guess we don't really need that there based on some previous USB example, whatever. Then we need the USB ID. For that we get this from here. We basically will not reuse really much of anything here except Apple. So panel vendor, that is Apple. I'm not even sure so what is even the benefit of having defines? I think I will not use those defines. Maybe there's a global define, like maybe we could, basically I don't like for numbers that I only use once, like why should I? We would need to rename it anyway to, I mean, we can rename this later again if people say, but, so what this does is tell the Linux kernel driver like match to this device. Also front panel, so we will also need to rename some stuff just to make some more sense. Minor base, okay, fine. So later we will delete most of this stuff, right? In flight. So, I mean, maybe we just don't change, you know what, let's not change anything much more here. Why does this not have a module? Module device. Apple, what was the other display, right? Apple display, let's copy this too. Slightly surprised this doesn't have a Apple xserve-frontpanel driver, also still us. Best without type, or this, this was just a Unicode hiccup. I'm not sure what freaking locale I'm using. This should be YouTube. Okay, fine, whatever. YOLO. Did I have, here, we could add this Xeon, because, or Intel, let's see what, let's call this Intel or whatnot. Or we just Apple Xserve USB, it's like, not to have other marketing names in here, it's just, whatever. So, so this will build but not work. We can however first build it. So also we need this in, I should say, because I started this last night, MISC, USB MISC. I also added this already here to USB Xserve, that is why in T2 we have this patch here. Also we could Xserve, maybe we should have here some spelling stuff. So here control the front panel of Apple, Intel, Xserve, so it's, have Intel and Xeon service also. We just take one phone call before we continue. 1 second. So, USB Xserve front panel. So we need a kconfig and we need an optional makefile entry here just for complete, right? Object. So this evaluates to yes. So if object yes to build, right, this will be just a makefile var for object dash j y on. Oh wait. Here, xserve-frontpanel. So then eval all of this stuff. This will build shortly. And we need to still delete most of the code there at the end. So we will, it's not as easy as stealing the skeleton, right? So we still, the reason I do this, obviously, writing this from scratch is super error prone, right? Even Greg Kratman, I mean, this skeleton driver made that over a decade. And yeah, standing on the shoulders of giants. And what you're saying, for what we writing news forever today into Apple, yep, exactly. Gets me said often enough. All right, okay. So let's maybe build this in the background, like there log to, yeah, I could, you know what, we could do it slightly more professional. And the second tmux, that's what we have tmux is for. And then we need to vastly rewrite that. Drivers, USB, LISC, Apple, oh no, not Apple. What did we call this? Xserve. So I don't have Xserve in the name, right? Because it's not just any Apple front panel. So name choice, in my opinion, it makes no sense to make it overlong. We could name it Apple, Intel, whatnot. In my opinion, it's already USB. It doesn't need to be USB, whatnot. So Xserve, it's only in those, right? It's probably the most. Other people use underscore, like YOLO, whatever, right? So this device that you may or may not see somewhere here, so that is the Xserve before I shut it down for noise reduction reasons. I don't have the scroll back. So it has no bulk in output, right? If you read about USB standards, there are various types. There are bulk data transfers and then interrupt data transfers. Interrupt mostly for reserved bandwidth for audio and such transfers. Wait, there's and Isynchronous for like audio and multimedia stuff, video. We only need the most simple form, and this driver does not have bulk in. So this driver here, so basically what we need to do here is delete the bulk in stuff because we don't have this, right? So this skeleton driver exposes this, I believe it exposes this probably to read IO, bulk and filled, copied, submit. This of course just a test, right? Skeleton read. So basically we need to delete all the read stuff anyway. I mean, right now it is 640 lines of just skeleton driver, right? But that is also something we will land on later. Actually, we can change this here already to, what was our name? xserve-frontpanel. So I propose to rename this stuff, like we will later rename this from skeleton to front panel or so. I wouldn't rename it. I don't like super overlong var names. I think front panel is enough. It's just static, non-exported symbols anyway. So they're not polluting global kernel namespace. And I saw already from browsing this in the web view earlier that this driver, the skeleton driver, only works if it has a bulk in and out. So this here, so that is probe, right? So we have here USB class driver in order to get a minor number. Okay, later we don't need this skeleton thing here. Okay, let's. I will delete it later anyway. Front panel. And so what we need is, so here's our skeleton driver, again later be renamed, endpoint descriptor, and so here it starts, right? So bulk in, we don't have an in, so this thing can only write to this front panelets. We only need bulk out, allocate memory for our stuff, kref init, so this is reference counter, like yes, Java like reference counting in your Linux kernel. I'm sorry to bring it to you. Many things are garbage collected, just like in real-time Java, just written in C for your Linux kernel C goodness. Allocate the stuff here, allocate memory for our driver state. Of course, in failure, like error handling in a single address-based kernel, vitally important. So all the stuff needs to be handled, otherwise null pointer references and so on, right? You don't want any out of bounds, any null pointer deref, any use of the free, and so on and so forth in your kernel. So reference init, the semaphore, maybe we don't need this. For now we can leave it here. Doesn't hurt for the moment. UDEF USB get device, interface to USB def here. So that's all the stuff I don't want to read. Like I don't want to spend a week reading the USB documentation, which is why I copy this, right? So we need a handle to the USB device that the Linux kernel auto matches us with given the vendor and product ID. The interface, so this thing has only one interface. I'm curious if it just will work, because in user space it didn't just work as easily, because somehow I'm more used that somehow the configuration is already set, so maybe we need to sparkle. And so maybe this will fail colossally, because in user space it failed. It might need a USB set configuration, because so what this does is USB devices can have multiple configurations, sync, gamepads, keyboards. Probably, I didn't check, but maybe keyboards have 2 configurations, like simple boot protocol and like more fancy stuff. And even audio devices can have configurations like a simple audio config and like audiophile audio config. So the USB device, the USB standard has some generic mechanism to configure different profiles of a device, but this only has once, and I'm more used that those devices by the kernel and by themselves come pre-configured. So this is the first device in a long time I've seen that doesn't do that. So maybe it needs that, but we will see later. Find common endpoints. So we need to change this already. This will fail because we do not have a in pipe. So if you are new to USB, you probably want to read standards, Wikipedia, right? We have devices, we have multiple endpoints, so their devices can say on the USB wire, I can read data, I can write data, I can do interrupt stuff. So I hope this works null. So we only want to find one bulk output here, couldn't find, so can basically here couldn't find bulk out input. And then we had here bulk in. And so we probably want to delete all this stuff already. Bulk in, so that we can delete, so skeleton delete, free herb, bulk in, what is this here? Read bulk callback, we don't read bulk. Do read IO, we don't do read IO. Skeleton read, don't need that, we only do writes. I mean, this will halve the driver in half, but we will add the spec later for in-kernel CPU. Load determination write bulk callback. So this callback is called, as you will see in a second, when we submit this USB request to the kernel, and the kernel will schedule that to the host controller interface, and eventually it will be sent to the wire when there is free time. And so this will give us asynchronous notification about its status. So here's skeleton write. Again, this will later rename. This is our callback from user space of this example. Later we will change this too. First I want this working, obviously. It's like limits the number of herbs in flight. It's like using up all RAM. It's like using up all RAM, 32 bytes at the time. So what do we have here? Down interruptible limit semaphore, down trilog. So this, okay, good that we didn't delete the semaphore yet. It's basically protecting these resources here. Then so creates this herb. This is this USB request buffer or request and a buffer for it. So that is here allocates this herb. If not, then fail. USB alloc current here, if fail, copy from user space. So later we will not delete this, but for now let's try it with this. And so then mutex log disconnect, if disconnect unlock inodev. So this is disconnected, fine, can leave this there, like if you pull the cable out, which will be difficult in the server, but so fill bulk herb. So that is all the stuff I wanted from the skeleton driver, right? The herbs, the dev, udev, USB, SND bulk, not sure what SND standard, endpoint, whatever, bulk. I hope that works. Good, send data to the bulk. So then we call the Linux USB subsystem of, hey, USB subsystem submits this universal request broker buffer thing, different kernel address types, mutex unlock, and then fail to submit or not, right? So either it failed. So this will still, so this will only release Java-like reference counting in your kernel, right? Or Java, whatever. So release a reference, this will be still in flight, right? And the notification for that will be, so right, so the notification, asynchronous notification will be skeleton, right? Bulk callback, that was then that one that we dealt with here, right? Bulk callback here with structure herb, use skeleton def, context, unlink false and errors, free up allocated buffer, USB free current. So here it is deallocated. And it's like, if you do not do this, copy this from another driver, like easily you spend 40-hour week of just getting all those reference counting and buffer deallocation right? Obviously not something we want to spend time with. And I would still argue like you don't want to write, like, yeah, in modern code, like in my opinion, kernels should not be that open coded C for a long time, but whatever. So struct file operations, we do not have read, we only have write, open, release, flush, else seek. What do we do with skeleton flush? What does that do? Flush, read out errors, leave, does it do? Okay, let's rather, this was herb read, I believe, or read herb. What was it even? Read, where is the next? Ongoing read is ongoing, can delete that too. Read out errors, I think we don't really need that either, but for now we can leave it in there. So we can register the device now as it reads. What else do we need here? Bulk endpoint, bulk out endpoint address, save our data pointer in this interface device. Let the user know that what nodes this device is now attached to. USB skeleton here we can, I mean, we will delete this later. We will not expose file operations, but whatever. So disconnect, what else do we have here? So read out errors, I guess we deleted all the read stuff. What else do we have here? So we have xserve-frontpanel, we have probe, so probe is called with a USB device. We still need to do configuration stuff. Disconnect is you pull the cable. Suspend resume is power management. Maybe it doesn't do here much. Whatever, I guess we can skeleton, scale drawdown. Whatever, USB call on. I guess, yeah, power management stuff. That's what we're here for, right? Like we want power management stuff to theoretically maybe work. So whatever. Auto suspend, no idea. Maybe we comment this better out because this device was already a little bit flanky when I tried it from user space. So maybe it builds, maybe it doesn't. Was already some, of course, there's some bulk out. Remember, bulk invade. Bulk in. I still have quite some stuff here. Didn't delete everything yet. So init USB. What do we have? A skeleton probe. Didn't finish cleaning this up here. Mutex init IO mutex. Spinlog init error log submitted. Wait queue head. You get device interface. Find common endpoints. In size and address buffer in buffer. Bulk in, we have only out. Disconnect, bulk in, submitted, USB kill, if time, what do we have? Drawdown, USB wait, anchored, empty, timeout, kill, anchored, so it's probably if they are stuck on the wire and don't send, like, if you want to unload this and there are some data transfer issues, as we have all seen, that's probably what that is for. So probably use of undeclared skeleton table. Oh, that's skeleton table. That is, of course, we renamed this. You know what? Let's rename it back to skeleton, and let's rename it last when we rename all of it. As we are now about to start, we could. So yeah, let's turn this on. That probably should come fully up. This will be louder. Attention for your headphone ASMR. Also, I pulled some cable out. Amazing. One U server booting. Oh, also didn't turn on our studio alert. I'm not running 6.8 whatever. It's probably compatible enough if we just change the version number. So normally you need in the Linux kernel build all in one tree. But I'm not rebooting. I mean, I could. Feels like we're gonna take off. Yeah, it will calm down a little bit when we are booted, and some more power management is going on as usual in firmware. Most servers, even PC stuff, in bootloaders and firmware, they consume more energy because they don't do power management. I'm just waiting here for network boot to proceed. Now we're network booting. Once Linux kernel is booted, it will be slightly quieter. And so error use of, oh wait, that we just fixed it. And we will change the version simply, so we will fake this to, let's see what we booted. Still hanging in grub 2, that's not ideal. It's like, yeah, 2024, actually 2010. The server's already some years old. 2010, and your bootloader consumes more energy than your OS. By the way, this is the only device ever, even including all the other Intel Macs, that has BGR frame buffer, so all the grub and Linux kernel simple frame buffer colors are RGB swapped. This will come down in a second. So what are we running? R682. So this will most likely work. If it crashes, we can still network boot another kernel, just I don't really want to touch the network boot stuff. Yeah, it will be less load. That's also why I started without that. They're changing the kernel version, probably rebuild some stuff. Basically could also... Hey, it's not as loud. It's fine. So this kernel, I don't expect super major things to have changed, so most likely this module will just load and work. Hopefully. It's a little bit... Is my voice loud enough over the minus 20 dB? So my voice should be 15 dB louder, so 2.5 times louder, I guess, plus minus. Yeah, the wonders of Linux modules and non-stable ABIs and stuff, like you need to build most of the rest just to build one driver. So what we're talking here is So this is that here, right? No, this is, oh wait, this is wrong. Is this one here, Apple, I think this one here, front panel. LS USB verbose for front panel controller here. So then, so that apparently worked, then copy this. Driver, this new driver, USB MISC, to here. Let's see what happens. Not info element. So we have here a new Apple, shiny new Apple Xserve USB front panel thing. And it insmotted and registered some now attached to USB skeleton 0. It did not yet crash. That's good. So where do we have, so that is, does LS, let's check with LS USB verbose. Would it, maybe it does, where does it show the configuration? So as you see, we only have a bulk out endpoint here. Not sure if that is configured there, but okay. Let's see if we got here the device node. We were promised one. Yeah, front panel 0. Amazing. So then let's carefully write, like, I mean, so we need 16 logs. So we have 2 times 8 LEDs. So like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the first row is, so this is ASCII. So this will be like 42 or whatever. Like 1, 2, 3, 4, 5, 8. 2, 3, 4, 5, 6, 7, 8. Also, by the way, maybe we use something less politically charged FSZ now. 1. And then we need some unused data. We couldn't, like, I think it doesn't matter. I mean, ideally it would be 0, but like, whatever. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. Let's, so that's what we want to write there, basically, to the LEDs. Word count that. So 32, that looks good. So then let's write this into front panel 0. Permission denied. That's not ideal. Why would that be read write? Why do we get permission denied? Hello? It's like, yeah, it calmed down. Hey, minus 30 dB. Okay, it is way more pleasant with the headphones, so I guess headphone it is. So yeah, so much to it. It doesn't work. Why do we get permission denied? That's bizarre. So it registered all of this. By the way, I could check if the LEDs changed. I doubt it did. They're still all off. So what's happening here? Right, bulk. Where's our file system? Here's our write. So here it should come in from the Linux virtual file system switch. Write size, max transfer. What is max transfer? Is actually max transfer should be choose that the VM is not stressed with 512 bytes. Max transfer should be 32 for us, and that is size T of count, the minimum of count. I mean, that should write 32. E restart system, E again, E pipe, E no mem, E fault, E no def. Return write size. Here we have the callback. So the callback, so basically we return success before it's written, because this is asynchronously called when it's eventually sent on the USB wire. So it would actually, you know what, we probably want to define debug. So it's unexpected. Why does this permission denied? Does it not even VR root? This should be ours or not? USB skeleton 0. Or is it not ours? So unloading works. So all of the stuff in a single address-based kernel can halt and catch fire, right? So all of this is also why I would prefer a multi-server microkernel thing where USB stuff can't crash your kernel. So did this disappear it was front panel, right? I mean, it is not impossible, so this is a little bit strange. It might be due to building a somewhat incompatible kernel, to be honest. Maybe we should boot the matching kernel. I mean, otherwise not really much should have changed. And we can copy this over again. And with debug maybe we get some... This should be now... Does it date and time even? Just to, it's always helpful if date and time matches, is it to check that something copied. So system-wide time zone. So this is a network boot thing, my test network boot thing. That's certainly also good to 54 probably makes more sense. So we re-registered that again. Probably got that again. Probably that behaves the same. What makes me wonder a bit is this doesn't strace anything, so I have suspicion the shell already says here permission denied. What am I missing? read write character. Ah, because it's character and not block. That is what we are missing. Or oh no, this should still work. I mean, later we don't even need this, so maybe it makes no sense to... So we didn't get any additional debug stuff, did we? With define debug. That's a little bit unfortunate, but also not really what we need. So what we do need is sending data in kernel, so I don't even want to expose it to user space. So we registered... I mean, it would have been a good first test to test this, actually. It's a little bit disappointing. But that's strange things. And certainly there's a very good reason. Like usually when you debug and go meditate an hour or two, then you usually find like how it was obvious why this didn't work. So let's basically probably delete the remnants of this file system stuff here and don't even use it. So where do we have writes in flight? So I mean, this thing we don't even need. This is probably only max transfer is only used there, yeah. And in flight sema init writes in flight. Okay, whatever. Minor base, also don't need that here. Maybe we don't even need this class driver. We will see later. Minor. Maybe we shouldn't start breaking it even more, otherwise maybe we debug even more stuff. Let's first try to directly write that, so that would be calling here our write in kernel. So that we struct file, buffer, so much stuff just to write 32 freaking bytes. You know what, if we don't have, maybe we already don't register this write stuff because I want to modify this more. Not sure if the kernel will like it without write open release. So this callback we need for garbage collection, and then let's make this our own const char buffer, not user buffer, in kernel buffer. And that's also complication in kernel stuff, right? We have memory coming from user that's not generally mapped, so you always have some API calls of actually accessing user space memory to actually make it mapped and is accessible in kernel. Buffer count and position, so don't need all of that. Let's see, what do we need here for def? Ah, right, we need this def here. So def is self. It's our own pointer. So I just modify this here, right? So we will pass this ourselves. We will make this in kernel. That's what we need. Our USB skeleton driver. Buffer. So buffer we don't really need, I would say. Def file. So this def we pass in. I mean, we could we could delete this because our own in-kernel stuff could always write non-zero stuff. Limit the number of herbs in flight, so non-block, down interruptible, stop a user from upcalling, using up all memory. Okay, I mean in kernel we don't really need this, but let's not totally break it instantly. So spin log, return val. So again, most of these details we don't even need. So we need to allocate this herb. This is universal USB, universal request broker block thing. Coherent. So this is, maybe we need this buffer after all. Is it this buffer? Or did I delete that? Ah, shit. We need this after all. So buffer mem. So here's copy from user. So that's what we do not need. So we'll copy. So this is taking care of copying from user pages. We can basically make this a mem copy. Mem copy, so do we call this user buffer? No, I changed this to just buffer. So we still need to copy, so we will have our in-kernel CPU load data later, like when we got this basics working. Where is this now? Ah, here. So this is a USB buffer, that is our supplied buffer. Right size. So yeah, this should not fail. So mem copy, what is this? Returns the same copies and returns the same pointer to desk. So we don't need to check this anymore. This will not fail. It will only oops in case of. So the user copy could fail with out of bounds and user mapping and stuff. So then, if not disconnected, error, otherwise submit this. So the only change is accessing our device directly, and so let's write this in the probe function. Let's do here a test. I mean, or we could make this static actually. Static char, whatever. Test pattern 32 bytes equals, oops, I hope that works in kernel, probably should. So with all this initializer stuff, it's always like, does it work, does it not? So that's the first, although I mean, it doesn't really matter. I mean, we could even use other on-off patterns, but... So that is the first row. Whatever. From testing, I already saw that these LEDs are super bright, so I think the brightness is mostly useless on this front panel. Everything not zero, like I with my eyes I only see, like, maybe it's logarithmic or whatnot, or just tiny voltage is already enough for LED to light up as much, because like zero, like 1 to 3, like after 4 or 8, I don't see a difference. Like basically at 8 it's already full brightness, so most likely that is pointless. But 1, 2, 4, 8, 1, 2, 3, 4, 8, the rest can be 0. And then let's interface and stuff, let's submit this in kernel, not to deal with this user space file system operations. Register dev, something prevented us from registering, not able to get minor. So later we don't need this minor version anyway, so YOLO. But so that is what, how did we call this? Skeleton write, def, buffer, count. Dev info. Alright, we could actually, maybe we do this, it's the last thing here. What did we had size t, right? Size t test, right? Our own def is what? Just def interface. Just def USB skeleton def test pattern address of test pattern size of test pattern def info did it succeed or not? Yeah, make it always recommendation. People always ask me how to start, like start with the most small tiny thing that doesn't work for you. That's already annoying enough to make working. Error, use of undeclared identifier file, private data. Save our object in the file private. Here's also open. What file private data? Why is this not? What did I skeleton release? I mean, we don't really need this class. Should we delete this now already? Gosh, I somehow did something. I think maybe it's just some scope missing because I don't even remember use of undeclared identifier 183. Skeleton, right. Oh, it's just our file, it's just here. Did I not delete this? Ah, maybe I deleted this and restored this. Oh, that's probably why. Yeah, that is always a danger. You clean this stuff up a little bit and you break it already completely. Enough for... Ah, there's more file. Ah, here's file. Non-block down interruptible. Try log, if not, fail. Yeah, in my opinion, way too much code. I would like, we need, and that's what people always argue, like kernel is complicated and C and whatnot, but in my opinion, this is way too verbose, error prone and stuff, which is also why I'm still dreaming about a microkernel. So there's some 341. Like that's what I basically want. That's what I mean with over 90% smaller. I mean this APIs and in kernel stuff is already pretty annoying. So also best without so many typos. And welcome everyone. No, sudo will not, I was already root, this will not change a thing. There was something inherently broken in some way, shape or form. Incompatible char, incompatible pointer types parsed. What do we have here? Just const char. Do we have here static char? Maybe I did the C pointer wrong. This is already a pointer, right? Don't do C for a week and already... Where is my test? Not already a pointer enough. Undeclared info. How is this on the... Oh, or did I... interface. How did I get to info? So many typos. Too many typos. What do you have here? Front panel, type in. Okay, YOLO, whatever. Size T. It's fine. Yeah, crazy long. Yeah, if just we had the microkernel as multi-server stuff. I mean, you could run this from user space with libusb. So let's see, will it crash or front panel? It wrote 32 without error. Let me see if something is on there. Oh, look at that. The LEDs are on. We very complicatedly wrote 32 freaking... It's maybe the first time ever. So like basically how many lines? 300 lines of skeleton driver it takes to write 32 freaking bytes. Let's post this to Instagram. Yeah, I know. I'm aware that even better would be a second camera, but you don't share and like and subscribe enough. So I need to resort to such low-tech measures here and can't afford a second camera. But here's a photo. It's maybe the first time ever that this Xserve LEDs have shown on Linux. Yay! So we only need to further transform it and copy and paste the rec, Ben H rec meter stuff. So yeah, the first line. So we wrote the same data. I mean, it's not. At least the camera can capture the dynamic range. Let me just... Okay. Okay, it is differently. So what did we have? 128-ish or so. So yeah, apparently that is still... I mean, it's with the human eyes, this is still freaking bright enough, but no. Anyway, we were probably just right to 55 in there as maximum 8-int thing. So, of course this driver is way from finished, it's just the first test, so basically that works. Let's change the test pattern so that we know it works. Otherwise, if we don't change the test pattern, I had this pre-testing this in user space last night, or this morning, that this device thing didn't work anymore, so let's change that, so that's the next iteration, we know it actually freaking worked. So let's delete this file operation things here. So we don't need this, owner this module, so we like this stuff can go too. We also don't need this class thing, so we can register the device now as it is ready. USB, do we... The question is, do we need this? I do not know. So it's this kind of stuff, even I mean, I do Linux kernel stuff every other week or so. But like if you one day hack on PCI stuff, one day hack on network stuff, and the other day hack on, it's like, you usually also work in stuff that's already there. So usually I don't have to deal with this boring, mundane housekeeping things of not crashing your kernel and leaking memory. So that's the difference between standing on other giants' shoulder and doing stuff from scratch, even if it's a skeleton driver thing. Do we have a class here of registers? It's Apple backlights. It's backlight. It's even... Okay, we have some backlight thing here. USB. What did we have there? USB register def. USB register. Okay, maybe we don't need this class driver thing totally at all. We can register the device now as it is ready. Something prevented us from... I think we probably don't need this. So probably only this is user space visible stuff, right, with file operations, I guess. Was def right? Linux manual pointer to register user space and ask for minor number. Okay, we don't freaking need this at all. So we don't need a minor number because this is not user space visible. So there goes that. Give up our minor number. We don't need a freaking minor number. Also, let's rmmod this. Minor. So we can delete this. We don't need a minor number. So minor numbers, these are the device node numbers that you see in /dev, where each class, like your HD, your serial ATA, your SCSI, your DRM, like a group of like devices or partitions have one major number. And then all the minor number, like basically your HDA, your NVM 0 are like major number 128 or whatnot. And then all your partitions are the minor number, right? Like all one major and then minor number or each partition, for example. So, oops. Skeleton driver. What else do we need here? Debug stuff, skeleton minor. So that's what we wanted to delete. Max. So basically, we could copy the second only other number. We could. All right. We need maybe. Okay, maybe we don't even need that, but we could copy that just to be. I mean, we could make the other things defined then also. I mean, okay, we could copy all of this. I mean, here's my. Okay, fine. You get your defines for panel vendor panel. There's basically no product USB ID. So max. So we have here panel data size. Let's sort this a little bit better. So we want, where was it even? Probably will error out. I think I deleted one. Yeah, max transfer was what I was. Max transfer. So we have here panel. Was it size? Right? What was it? Data size. And let's correct this one warning of LD of long double. Certainly Linus Torvalds will not accept this with a bloody logging warning. So then use of undeclined minor base. This is a whole class thing we don't need actually. So are we down to how many? Hey, only 407 lines of code for setting 16 LEDs. So yeah. So, but we need to determine the load scale. Okay. Scale, more stuff to delete. Skeleton open, we don't need. Release. Flush. Right, all we want is that. Skeleton delete is, what does it do? Scale delete. USB skeleton dev tool, where is that? Put scale probe. Okay, fine. Delete this stuff. Then I'm sometimes in France, yes, but right now we are live streaming from Berlin. Let's just grab some coffee and fix some more stuff. So while the coffee machine warms up, let's see if it still works. Also prototype test each iteration. You never know when your Linux kernel API stuff blows up and shoots yourself into the food. So far, so good. Strange. I think it worked, but the test pattern is... that is why I changed the test pattern, because now everything is bright. Like maybe one line of LEDs has a different brightness. That is bizarre. But let's maybe change here. Let's make it some pattern. I would hope this bloody microcontroller supports it, but you never know what bugs Apple has. It's basically also setting a zigzag pattern there of... this will mod post a while again. That works. So yeah, maybe this may call me crazy. It appears to me that the second line of LEDs have a different brightness. So Apple engineering quality at its finest. But so that worked. Now we have a... I mean, I have the one off by one, I believe. As you do when you quickly clobber some test data. So alright, because the first one, this one I didn't. So 0, it's probably the 0. But so yeah, it works. It's just testing like how reliable is this stuff? Like, does it instantly, like, is it very glitchy and touchy? Like one wrong packet and stuff and it crashes, but so far so good. LEDs are changing. Everything is better with hardware fully working, T2 Linux and a good black coffee. Also don't delay, donate coffee. What was the... buy me freaking coffee or Patreon for all this AAA hardware enablement and educational video stuff. And of course, did you know I run T2 Linux, and T2 Linux will be the first Linux distribution who obviously supports this superior front panel technology. So, as this works now, step 2. Only 1 hour to make this work. Yay! I mean, this is crazy, right? Like, in my opinion, you could argue all day long about microkernel, monolithic kernel, but like, it should not require that much C code. I mean, hey, it's only 330 lines now with all the surrounding stuff here. But like, you would not want to write this from scratch. And okay, it's like maybe 200 lines effectively, but so now we will add even more stuff back. So let's make a backup already. Diff u diff no there. Let's save it there. Just in case we majorly mess it up, because now we need to implant here a whole of driver Macintosh rec meter. So in my opinion, there should be, like, if I would have been Linus Torvalds or stuff, there should be a generic Linux kernel load trigger, because we have like triggers are like LED triggers, right? Like caps lock, scroll lock, like heartbeat meaning your system is alive. So that's like what you have on embedded stuff, right? Like heartbeat. So this triggers you can select in the Linux kernel LED class subsystem for your LEDs, or like I/O load or network trigger. And there should have been a system load trigger, but there isn't, because there's also other hardware. For example, IBM RS6000 workstation and servers. I have two. They have a display. You could display the load on a 4-character display, for example. I've done that 20 years ago just for kicks and giggles and fun. And so because there is not a system load, for example, if there would be a generic trigger, you could, for example, assign that to the brightness of an LED. So, for example, if you have a Raspberry Pi or RISC-V Vision 5 Zero, you could, like, if that would be in place, you could, like, set an LED to shine brighter with CPU load, for example, or use it as this rack meter thing here. But because there isn't, we need to steal all of this driver. Also, I should not tell this the Linux kernel people, because if I submit this driver, then they will tell me, hey, can you first factor out like this code here? Like, it makes no sense to have this code twice. I mean, yeah, you obviously not, but I'm not Linux Foundation employee to refactor shit all day long. So because of that, so how many is this? 600 lines of that code. So we will steal some of that. Number of samples, let me just sample count. So, because as far as I'm aware, that is the only other place in the Linux kernel, which ironically the predecessor, the Apple G5 Xserve, which we also have previous live streams, obviously. And yeah, that's the only other driver that is sampling CPU load. And so obviously we want to reuse it. So as I said in the introduction, so absolutely crazy, this G5 VU meter is using I square freaking audio S for I squared sound. It is sending the VU meter LED data by I square S sound audio protocol stuff. Absolutely crazy. Maybe Apple had this audio stuff left over from iBooks and stuff. It's like, hey, it's the ideal thing to wire LEDs to. So I guess absolutely crazy. Obviously we don't need all this here, so let's maybe, where do we do that? Like, so let's probably implant that here at the end somewhere, or like maybe here where we can reuse it instead of our test data. So let's read in all of this file here. Let's copy the copyright, because we are super nice citizens of the open source world, and put that here of so let's put that here based on USB skeleton and based on Mac. What is the name of this thing? Rack Mac VU meter driver, so nothing like some good IBM and Linux Foundation stuff. So why do Linux kernel copyright headers usually look like this? Because of course the greatest artists always steal the code together, right? I have a distribution to run, I have stuff to do, right? Sun to see. Apple Xserve USB stuff. Do we need this line? Paste and rack VU meters. Of course, the stuff needs to be like, why do I do this now? Not that people later say we just stole all this. So that's there based on rack meter, VU meter driver, copyright there, IBM Corporation, and then based on that, copyright there. Good. Then we need to edit most of this rack meter stuff away. So we need to edit where's that? Here's that. So we are right. We might need some headers. So what we need is, so we don't need all this Mac I/O stuff and Keylago. Keylago is a Apple Mac 99 chipset of G5 stuff. So we don't need all this Mac I/O. And not this open firmware IRQ. So probably the only thing here is Kernel-side. Is probably the only new thing we need here. And then let's see. Then we need the sample count. We need to check here. So rack meter DMA sample count. I have U32. What is sample count even? 256. Okay, here's our rack meter CPU sniffer thing. Rack meter RM. I guess here we stick our. It's like, so even YOLOing this together will likely take another hour because we first need to understand what this rack meter stuff is doing here. So that's our rack meter driver. So Mac I/O. So we don't have that. We don't have that. Okay, so they have two rack meter CPU things here and paused. And okay, let's see. I mean, yeah, we could implement the same ignore nice things if we wanted to. So we don't have some GPIO to work. This copy CPU frequency on demand maybe should be put into common header. So get CPU idle time. Okay, we need that. Get idle time. So what do we have? Okay, so that computes the idle time. So that's what we need the kernel statistics things for. So set up I2C, let's see, that probably only programs the sound, I2C like sound data stuff. So Mac I/O is the Macintosh I, like either like low-level I/O things that we know from Mac. So this is just this I2 audio stuff, I2 sound stuff. Set default pattern. Okay, here we have this buffer, so they write this to this U buffer here. Do we still have this somewhere or not yet deleted? U buffer. This is struct rack meter. Okay, let's see. Rack meter do pause. What does this do? Pause. Not really sure what. Okay, pause. I think, alright, so I think I looked into the original code already. So because this original code does DMA for power efficiency reasons, Benjamin Herrenschmidt went the extra mile of actually stopping DMA. Like if the load is 0 and no LED are shining, he went the extra mile of stopping the I2S DMA transfer. That is probably what this is about. So I mean, we could actually do the same. Like basically we could actually stop sending USB packets. Okay, maybe we actually could actually use this. So memset sizes vmark. Okay, we don't need that here. What is MB doing? Let's leave it there. So set up DMA. So all this DMA stuff we don't have. So that's here are marks, high watermarks or whatnot. Of make sure just reset. So prepare. Again, mostly code deletion. So prepare DMA stuff. Setting audio stuff up for your server meter. Only Apple engineers think different. Audio server engineering, like only like Apple does. Rack meter do timer. What does that do? Maybe we need this. So probably we need that. So that probably rack meter CPU container of. Okay, so this computes, we do very dumb calculation to update the LEDs. No, we better, once we have pulse width modulation. Now check if LEDs are all 0, so we can stop DMA. Matrix lock pause, do pause, delayed. So they do delayed work on. So what we basically can do instead of we don't, what does it do? CPU sniffer, do delay, schedule delayed. Is it rescheduling itself or work meter do timer? So it's its own work queue maybe, do work on CPU. I need to check later. Okay, so init sniffer works only on with 1 or 2. So that's actually, wait, how many are right? Actually, you know what? It's actually way more complex than I thought, because I overlooked something. Shit. Which is even which here? You know what? It's way more complex. Quickly do a server load thing 2 hours later. Like, because that is a so basically we need to do this per socket. We have two, like even this mid-range thing has two E5520 Xeons. So we basically want to do that per socket, right? So actually we would need to iterate per socket freaking data. Oh, darn it. That's inconvenient. We could implement this as a first step. So by the way, CPU scaling, does it currently scale here? Okay, anyway, let's not get sidetracked here. So that's the thing. So the original G5 only was dual core or dual socket. What we need to do, here's actually for each online CPU. Init CPU sniffer, driver only works with, so we need this per socket. That's unfortunate. So original driver only works with 1 or 2 CPUs, numbered 1 and 0 and 1. But that's all they had in an Apple Xserve. Okay, so here is... Okay, actually we do this, wait, they have here get CPU idle time. What do they schedule here? What do they schedule? Schedule delayed work on the sniffer thing. I mean, we could, the question is how this, so yeah, the code there will be ugly. So basically what we eventually need to do is, we need to determine the sibling grouping, and because we have hyperthreading and wait, this was small enough. So we have 16 threads even on this old system. So it's dual quad core with hyperthreading. Highest performance Xeon you could possibly get 15 years ago. Yeah, so what does this rec meter do timer? Rec meter do timer. I mean, for now we could wire it to CPU cores 0 and 1 and later spend even more time. Why has nobody ever done that? Some dumb YouTuber live on Twitch tries to do it. Even 32 freaking LEDs are, 16 freaking LEDs are freaking complex. Hey, now that I think about this, we could do it slightly differently. We could, you know what, we don't need to do it like that. We could, bright idea, we don't, because we could implement either another mode, meaning we could actually map each thread to an LED and modulate the brightness. Would that be cooler? You have 60 LEDs and they're all your CPU threads. We could even implement both modes and have the user toggle it for outstanding Apple Xserve blinking lights. Yeah, of course it's super much overhead and annoying to schedule 16 freaking workers of schedule delayed work on CPU. Do we even need to? Why? Okay. Okay, so for every other CPU they just break out here. I mean, first we could get it to work and then we could further polish it, right? Okay, here is the setup. So we don't have I2C, we don't need to set a bloody default pattern, we don't need to set up DMA or whatnot. So init CPU sniffer. So what we probably want to do, here's also, so what does this calc sample do? Not yet, this is 0. Not even sure what this calc, what does this do? IRQ, so we don't have IRQs, so this is just flushing buffers for this I2C stuff, so flush PCI buffers, yeah. Make sure the CPUs get us in order. What does RMB do? RMB? Is that a... what even is that? Some PowerPC barrier? Prevent loads being reordered across this point. Okay. We don't do efficient DMA stuff on Intel. We just very inefficiently send slow USB things. Read mark, warning, rec meter incorrect, DMA mark, who cares, we don't have DMA. Next buffer, fill mark, fill it for now, samples, calc samples. So fill it now, this requires converting the 8-bit def sample array into a pulse with bitmap for each delay. I have some, you know what, I have the feeling they do they directly play audio data somehow on the LEDs or what? Anyway, so we don't do here fancy stuff. Also, if you want to implement Benjamin Herrenschmidt's pulse width modulation audio stuff for the G5 racks, be my guest and implement pulse width modulation stuff here. So 8-bit def sample array into each bitmap for, we don't need all of this. So, rec meter probe, we have our own probe, so that is for the Mac I/O open firmware matching. So no I2C for us, no open firmware device node, no I2C, I2S child. Light show, sound visuals, not like no light show. We are poor Intel children. Initialize instance data, we have that already, def there. Okay, so rec meter, wait, they have, this is the Mac I/O square semaphore. Here's some anyway, if 0, that's already 0. Address to resource, debug, get free page. What is a sample? I mean, sample, we don't need a freaking sample page. Huh? We just need the freaking CPU load and send a USB packet. No DMA, current alloc, IO remap, Mac IO, we have no DMA. We have still no DMA. Okay, here's the setup. So, okay, so this reg meter setup I think we have, right? Reg meter. See you soon too. Raiding with the party. Happy to be raided there. I hope you enjoy our Linux development here on this Intel Xserve. So, setup. So we have here start CPU measurements. So, okay, that is doing surprisingly little. That is just doing init CPU sniffer. I guess we can remember init CPU sniffer, right? Init CPU sniffer, and so we don't need this, not doing much. This was init. Init CPU sniffer. Then let's wire up more stuff. This can fail. Can't really fail here though. Request IRQ. Okay, we don't have an IRQ. Okay, that is surprisingly little that is left here. So all the other stuff is just open firmware, Mac IO and stuff. What is with the sniffer stuff? Okay, we need to stop sniffer. Timer and work queue. So let's copy that in here. Okay, let's wait a second. Let me type probe, remove. Stop. So all the DMA stuff, all we don't need any of sample buffer. Okay, so also shut down. Not really sure what is the difference here. Because this just stops that. Okay, so this is all reg meter, Mac IO stuff we don't need. Reg meter, init, exit, Mac register, module. Okay, so then stop CPU sniffer. We need that. We need that in either disconnect or... Oh wait, we don't have a... So we don't have this miner. Why is it still in here? A miner. Okay, but we need it. We don't need it anyway. So then we need to copy this reg meter data that we had somewhere. So I don't, okay, we can reuse the sample rate. So the samples we don't need, so this is 4 times a second. 50 milliseconds. DMA we don't have. Samples, what do we have here? Sniffer, rec meter, CPU, previous wall, idle. Okay, we actually need that here. No, we don't really need this cache line align. Not really sure why they did this. This doesn't, or, oops. Yeah, I mean, we could, if it builds, we can leave it there, YOLO, whatever, and it's cache line aligned. So delayed work sniffer, rec meter, so that we need a, so that is front panel. Did we name this front panel already, or? So that is our USB skeleton. Or do we even? USBs, wait, not, so where is my lost in here? So struct, I think was it USB? I mean, maybe we should freaking rename it now. Let's rename it to front panel, otherwise it gets confusing for people to watch this later. Front panel USB skeleton of static struct USB driver. Yeah, I should substitute. How many do we have? We don't have that many, and it's a little bit error prone, so. Let's copy and paste it. So here's our front panel. That's why I want to change that now. Front panel. RM, but yeah. So this is a previous wall clock time and the previous idle time from this stuff we have stolen from Benjamin Herrenschmidt. Rec meter was a previous, so this was a previous Mac IO thing. We don't need that. We only, so rec meter CPU. So basically, so we need this, so 16 times mutex, whatever we had set. So then let's move that here. Let's move that there. And whatever. So then here's our rec meter stuff. And so we need to move this into our, here we have this IO mutex thing. Maybe, what was it called in, it was just called mutex, wasn't it? Mutex? IO, also, yeah, whatever. Okay, let's better not touch that. So we need this rec meter stuff in here. In our driver. So Let's just name it regmator, whatever, and but let's maybe name this front panel to better see that we still need to change this somewhere. So, delayed work sniffer. Benjamin Herrenschmidt has chosen that, not my name. I'm not substituting all this stuff. It's also then easier to fix bugs in both, and it should be made generic, but not today. So USB device, UDEV, what was MDEV from Mac IO device. Interface, semaphore limit, so maybe we later remove that too. It's a little bit U8 and stuff all over. Not the greatest fan of these alignments here. To be fair, spinlock, struct kref, IO mutex. Because it's also like, why did they make this disconnected a freaking long? Or is it for... Okay, you know what? YOLO. Leave it. Let's leave it alone. So rec meter CPU 16 times and paused. You can cut where X is, you can cut DXD. So, the front panel. So what else do we have here? CPU. What buffer? Okay, we don't have RDNA buffers here. This is also a synchronization primitive, don't need that. Default, I also don't need a freaking default pattern. Whatever. My stuff can look uninitialized for a split second. To be tunable, I think I want tunables at the top too. And it's like, how long are we in? It's, of course, I was sure it will take at least 1 hour or two. I mean, it's not even freaking working yet. I think for simplicity I will simply make this modulate the brightness, because otherwise grouping it by socket is like literally more work than moduling it of the 16 LED dots by that. So get idle, CPU stuff, rec meter do pause. What do we have here? Rec meter. Okay, we don't even have DMA here. Paused. Yeah, still need to change all of those. Here's DMA stop. So we could basically... By the way, we could actually always... Now, we do you know what? I think optimization second, like let's not even bother with stopping here some stuff. As long as the stuff is running, it's updating this. We have Intel CPUs, we have CPU cycles. Rec meter do timer, work of container of sniffer, rec meter CPU, container of work, struct, rec meter CPU, sniffer, work. I think we had this rec meter CPU, right? Yeah, we have this CPU. But basically we need rec meter CPU container of work container of work in sniffer work. Okay, so we have here front panel, so that we need RCP or RM. Alright, we need to fill those RM things. So that is FP, so we need USB front panel. USB front panel. Front panel. SMP processor ID, all this stuff, Jiffy stuff, previous wall, previous idle. So dump calculation of these LEDs for now, better ones have actual load is set, total and stuff. What is this int? What type does it have for load is an int? Offset is CPU. What do they even do here? They do have really strange stuff. I mean, 0 is. Okay, do we still have this 0? We still have this 0. You know what? I think I want to keep it most stupid simple for now. I'm not in the mood of dealing with this nonsense here. So all we need is the load. Should this be like, what does it even? Division 64, U64 of, why do they have 9? Or maybe it does, so this is 9 times total of minus idle. Okay, so that is probably scaling this up to 9 or 8. Maybe it can go up to 8 like that, I guess. This is formulated stuff I don't need for now. In my opinion, yes, it is kernel code and stuff, but I would still argue this should not be that. It's like, yeah, no, so what do we have here? Why, this is okay, you know what? Wait, okay, we could actually leave it after all, maybe. What do we have load per? I know this is full system load. Where do we have? No, but no. Scheduled late work on sniffer. Sample rate. Oh no, it's I'm not dealing. This is too auditive. Okay, also not with that. Okay, we could allocate this buffer after all. They had the sample buffer. Very dumb calculation updates. Let's delete this again. So this is. So we have the load here. What do they do with the load? If not paused, then oh wait, this is only pause stuff. What do they wait? What do they do with the freaking? What have they done with the load? They fill. Wait, but. Here they fill the load for. Here they do this into this buffer. Where do they get this offset from? Is the offset simply the CPU or? Yeah. Init CPU, so struct, what was our name? Regmeter and regmeter CPU. Okay, so we need some sample buffer after all. Let's steal the sample buffer again. What do you have sample? Okay, they have a way larger sample count. They had this in DMA. Let's remove this stuff. We know how many LEDs we have, and it's also somewhat pointless. So let's have a U8 buffer. Oh, this is it. Let's make that as, yeah, let's make it as large as the SAM data size there, panel data size. Let's write those samples directly in there. Welcome everyone. Just a tiny little bit amount of getting some CPU load data in there. So rec meter, we have CPU, we have 16, maximum 16 threads here. We have some do timer, init CPU sniffer, delayed work. So next, init CPU sniffer for do we have the rec meter CPU? Did we call the CPU? Oh, we called the CPU, okay. So we can delete this here because we have more threads than G5. Init CPU sniffer for struct front panel. So front panel CPU, let's not initialize two things here. Front panel, what do we have here? CPU, right? Do we have for each CPU? They should be correctly numbered, shouldn't they? CPU front panel equals front panel. Init delayed work for front panel CPU sniffer for rec meter do timer. I hope this works. We need to do this for each CPU. So the previous driver had this hard coded for 2. We do it dynamically for front panel, CPU, CPU, front panel. So this is a pointer to ourselves. Init delayed work for Z CPU sniffer, sing, rec meter do timer, and if CPU is greater 15, theoretically size off, but whatever. Front panel CPU, let's initialize this is rec meter CPU thing is just initializing that to the current CPU things. So this needs then the same here. For each CPU, cancel this delayed work. Oops. So what else do we have here? All right, we have this init, init CPU sniffers, probe. Do we have here init set? Hey, we're getting there. We are probably relatively close-ish to CPU sniffers for self. What is our self? Def. Def USB skeleton def. And then rec meter. So probe stop. Do we have this stop already? Stop CPU sniffer. Stop CPU sniffer. Stop CPU sniffer. Def. And also best after initialized. So here USB get. Nothing like random pointer things in the Linux kernel, and welcome everyone. Then we are still not sending, so we could, I mean, this will not build. We are probably like a dozen compile, static compile type checking things away from that even to build. Unless we're super lucky, but usually people are not. That's a few called undeclared to skeleton def. Alright, I changed this to skeleton. So what did I call that? I renamed that to front panel def. You know what? I think we can shorten that. Or was it only one? Really? What else? Incomplete type USB skeleton. Incompatible type of to scale def. Unused FP front panel RCU. Unused I. Unused offset. Will not be visible. Declaration of struct front panel rec meter init. What was even, so we have, oh wait, this is the wrong file. Rec meters, CPU, struct USB front panel. Did I somewhere struct front panel? Okay, let's see how much. unused, so 233, 238. Unused doesn't matter, but there, what is this front panel? Alright, probably previously it's probably unused, so do timer. Do we have... Ah, here we have CPU ID. So we still need to store this somewhere, so let's store it in front panel. You know what? Maybe this is not... it's probably not ideal to clobber all this stuff like 8-byte non-atomic size. I mean, maybe an intlet's fine. So basically what we need here is buffer, like store the load, and like basically what we probably want to do is like multiply this with something like that and store it in our buffer per CPU equals load. And we better cast this to, like we had here, like underscore U8 or stuff. We still need to send the USB packet, but that will be a travel, hopefully travel thing. I mean, I wonder if we even need that so stupidly. Like, is it not enough if we have one delayed worker and like iterate all online CPUs in that? And should this not work? Maybe. Yeah. I mean, Benjamin Herrenschmidt is one of those kernel god programmers. He probably knows what he was doing. Okay, complete definition of... What else do you have here? Unused offset, use of undeclared RM. Okay, we have here RM, fair enough. RM became front panel. Wait, there's some more. Rack meters, stop, struct, USB front panel FP. For each online CPU FP sniffer. Size of incompatible, incomplete type, struct USB, forward declaration of USB skeleton. Ah, maybe we have, is it a rename? Did I rename this already? Yeah. USB skeleton, USB skeleton. So we have, of course, now USB front panel. First we need this working, then we make it pretty. Welcome everyone, new to our channel. What did I have even written there? Let's see if that still blends. Offset, hey, only 2 warnings. That is significantly... Okay, let's not even try to run that because it won't work yet. Or should, I mean, okay, we could, let's run it and see if it, I mean, these warnings are YOLO probably. Unused in statics. Front panel driver. USB driver, why is this not? Maybe that's a bug in the original skeleton driver or static USB front panel driver? Or is it a static static struct? Maybe that's a bug in the original. I mean, bug of having that. I mean, we could check that though. So yeah, the first smoke test would be, does this crash or does it work? CP. Doesn't crash. Hey, so far so good, it didn't crash. That's a good sign. That's making every kernel developer happy. So this offset was also unused, so basically, nah, I don't need offset here. Basically we can group that tier of unsigned and load, maybe, or unsigned load, maybe is more slightly more readable, potentially, maybe. So let's send this bloody USB packet. And that would be here, our skeleton driver, right? It probably worked, right? Yeah, test 32, that of course worked. Oops, where's my... there. So, also we don't need this test pattern then there. So I would say as a poor man's first implementation, so I think with 32 it makes no sense to have 16 scheduled sniffer things here. I think we should do this here like once for all online CPUs. I think that would be much smarter. And can we out of here write that shit, no, I messed my copy and paste buffer. So wait, do timer, like how of... Oh no, this timer's a little bit... Okay, yeah. So let's do like... Obviously we don't want to send a USB packet for each CPU, so let's... Again, this needs to be done way smarter, but like if CPU equals 0, then do that. I don't know if this logging and stuff is here work queue safe. We will see if it halts and catches and burns and halts and catches fire and crashes and clobbers our precious expected, yeah, best result typos. Use of test pattern. Ah, right. So we don't want to send the test pattern anymore. Test pattern. Let's delete this. And write our actual data, which is here F. So basically, we could also, this was panel. Wait, do we? Okay, we can actually, so this is data sizing, right? 32. Oh, our buffer is data, panel data size. Okay, then let's make this panel data size. I like to do most of my stuff always on size of the stuff to immediately like write the correct size and make it fail if something is wrong, but for now let's do this here. And that is FP font panel buffer should probably, the only question is, did I had size, was the size initialized or use of def in interface def FP, wait, what did you say? To use of undeclared identifier 2.6. Here as this thing. Do we not have this def? Does this def work for that? Yeah. So make experiments. I don't want my stuff crashing unnecessarily with nonsense. Coolux scale driver. It's probably older, right? Def scale right. Front panel. What did I have there previously? Alright, since we need, where do we assign that? Probe is font panel def. Actually, this should have. Alright, I have def there, right? So that should be front panel. We have the FP right for do timer in scheduled work of that. Hey, 0 warnings. In C that means it will probably hold, crash and catch fire. In Rust it would mean it's probably fine. So we are writing data. Okay, all LEDs are off. Let's build something to have some. Oh! Oh man, is that cool. It even freaking works. Just do I have here freaking, do I have here square video? Actually I think it's we're currently live on Twitch and YouTube doing cool things. I'm surprised it didn't, like, I think we want to further rewrite that. But yeah, surprised it works, and let me just upload that for you, and the more you share, like, subscribe, the more we can purchase a second camera. Where is freaking... Do we have here somewhere? Probably. There is a flick. Ah, here's crop. The URI failed. Do we not have somewhere? Damn. Where is the freaking size of this Instagram nonsense? Add sticker, add audio, edit. Where is freaking kernel developer tries Instagram and is shocked by the fail of UI design? Split, replace. Ah, yes, but crop. Did I not? Oh, can you not freaking... How to freaking... So that is so silly. You know what? This is rather silly. Damn. Okay, I guess you get it how it is. Whatever. I can refilm this and yeah, we are basically 20 average viewers and 110 subscribers of not making this stuff up. It's blinking. If that probably is kind of sort of cooler than the original. So on the G5 only has a max of 2 CPU sockets, single core, and so yeah, we map one-to-one the brightness to the LEDs. Amazing. Didn't expect to get that far and do that. So yeah, I mean, it's kinda cooler like that, I would say. Then yeah, I mean, the other would even be more work. So let's back up that. I think online CPU. So of course it needs a bit style cleanup and stuff, right? I think we only want one timer sniffer thing, don't we? Delayed work sniffer. I think we want that. I think we only want that once. And okay, this is in here, so delayed work, so that is sniffer. In my opinion, it makes no sense to have 16 of them. So we have here rack meter. No, we have here actually struct. No, we have here struct USB front panel container of work struct. This can easily hold and catch fire here. Rack meter front. Hope that works. So basically, so then we do this only once for all CPUs. I think this would make so much more sense. Should the jiffies... I mean, all is CPU idle, don't we? Get CPU time idle, CPU... Is this even accurate here? I hope, Benjamin, may. How much CPU scheduling has changed in 15 years? Can we rely on, because they have here, idle force, previous wall clock time, previous idle, any other previous wall, previous idle, So, not that we rewrite this and then Linux kernel developers tell us that it's totally unsafe to calculate CPU time like that. Where is my time here now? Do time. Total idle, previous. Total idle, previous idle. I'm not sure if that is highly accurate for CPU frequency scaling and stuff, but I guess... hi, by the way, and welcome. I guess it's accurate enough for a bloody blink and light CPU load thing. We don't need to over-dramatize imprecisions of CPU frequency scaling. But what we need to do is, so we have here jiffies to get jiffies. The only thing is maybe we don't need previous wall because we only need this once, right? So basically previous wall also, we totally don't need this. Totally don't need this cache line aligned anymore for this few data things here. Someone is vacuuming today here. Our Xserve is vacuuming. So let's further wall, previous wall. So our CPU, so that is current, so this is current, that's how many jiffies elapsed there. That's probably relatively similar to a CPU's minus CPU frequency scaling, but YOLO, I guess. Current, so that is FP previous, so that is total nanoseconds. And then save this to previous wall clock time. And then online, so then we need online CPU. So for each online CPU, basically, so vastly change that too. What do we have here? So we don't need that anymore because we have that in the other struct there, so we don't need that. Init delayed work only once, not 16 times. That is FP sniffer. Meter to timer. Then only for 15 CPUs. And don't install wall clock for all. So only fp wall once, and then so for each store RCPU get idle time, so RCPU previous idle, so only store previous idle. I hate them. And then so schedule the work only once. Every CPU sampling rate. And so this was for each online CPU. So here, basically, you know what, for each, so here, so current total jiffies, get jiffies, previous wall clock, total nanoseconds, previous wall current nanoseconds. Get, so then for each CPU get idle time. It's idle nanoseconds total minus previous idle, minimum of that idle nanoseconds, total nanoseconds, previous total idle, what total idle? Okay, that is total idle. Total idle. I hope that works. Load. If someone finds there a problem in this, let me know. So if buffer equals load, CPU, so then we don't need that because we are only running on one CPU. And reschedule delayed work for FP sniffer there. Will it blend the first time or probably not? Previous idle. Previous idle. What does it complain here? 248, 248. Uninitialized when used here? Initialized with RCPU. Here. Thank you, compiler. That is correct. Let's copy that. What else? Expected sniffer. Oh, sorry. Of course, not an extra dot there. Nobody freaking catch that. Sniffer, 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 dot, schedule, delayed work on. No member named sniffer instruct CPU. Here is still stop. That's correct. Stop CPU. We only need to do this once now for FP sniffer. Crazy that a Ryzen 1750X is building and linking that, so like mod posting 10,000 or 6,000 modules. Yeah. Oh, that doesn't. We're finally our first oops. Unable to handle page fault for somewhere in supervisor access and kernel mode. In page fault queue delayed work at timer on. In driver probe queue delayed work on at timer on. That's more how kernel development really is. Your audio doing that bug more today could be electrical from the Xserve. That is not ideal, but thanks for letting me know. So what did we, something we did not initialize maybe. That's unfortunate, the stuff was working. Why did we further refine and clean it? Skeleton for device now added. Okay, that is, what is driver probe, really probe, USB probe, skeleton probe, queue delayed work on, so that is rack meter, init CPU sniffer, init CPU sniffer. Init delayed work sniffer. That the Linux kernel says queue delayed work on at timer on. It said page fault. It said somewhere. Oh, there. Some random address. Unable to handle page fault for some random address. I mean, the do timer thing is only here. I mean, I could imagine this one could be off. We changed this for container of, but I think it's just here already, right? Init CPU sniffer for front panel FP. Init delayed work. Previously it was address of CPU sniffer. Struct delayed work sniffer. RCPU sniffer. Queue delayed work on. Doesn't instantly look that bad. We call this here rect meter init CPU for dev. And dev is our USB front panel. Struct USB front panel. Previous wall clock time initialization. Init delayed work FP sniffer. We did allocate that here with size of dev. Anyone sees a typo here? That the compiler doesn't. Struct delayed work. We probably didn't get to this. Keref. Where is that? This here, this can be the same name. One is a type name and one is a instance name. That's fine. It's C. They got that. So we probably can't unmod it now. By the way, why do we have this twice or what? Yeah, now it's in use and now we need to reboot. So that's unfortunate. Yeah, to no surprise, Guru meditation most time consuming and single address space. And this is also why I want multi-server microkernel, right? So the struct thing should work. I mean, it didn't crash before, so init delayed work. Delayed work. Wait. Why do we have here, by the way? Maybe that's an issue. Was it init or schedule? Maybe we want to... So this is maybe out of bounds here, actually. That might be the issue. Maybe the CPU is off by 1. After the iteration, most likely. Where do we have... Did we not previously had here somewhere like current CPU? We had here init for each online, schedule on just that CPU. Here we have that CPU SMP processor ID. Let's use the one that's the one we're running on. That's so unfortunate due to the nature of single address-based Linux kernel stuff. We now need to reboot. We can straight this. It's network boot anyway, so we don't have any data corruption, right? This is like my network net booted NFS test environment. This proc this request trigger. That should instantly reboot. So then we don't have any kernel locking of corrupted data and logs and stuff. I press the N for network boot here. And we should be good to go in no time. Now we're good. So yeah, most likely, let's hope, fingers crossed, that's the only bug. It was, I mean, we majorly refactored that of having n work queues, one work queue per CPU, from n to 1. Maybe I should rewrite the G5, or not rewrite, maybe I should do that for the G5 driver too, while it... Also, maybe not, because we have a microkernel to write. I have to say, inadvertent, I mean, the good thing is that T2 logo is not color aware, color sensitive. I mean, it looks interesting, like RGB swapped. I mean, at least we have a logo that can be RGB swapped. Maybe I post this on Instagram for a little bit more live coverage of such fame here. And one person already asking what that is. These are necessities for gracious living. So you could reuse that, right? We could also do like you or me, or we could, I mean, I did 8-LED stuff on parallel port 30 years ago, 25 years ago. So we could actually build, use a TNZ or whatnot, like microcontroller thing to have something compatible, like protocol compatible for DIY stuff here like that. Insmod or xserve-1. No, it also failed already. What did fail now? Page fault address, still some page fault address, and we built that and copied that, right? It's not ideal. So yeah, for serious work, exited with accused disabled. What do we still have? Does it look identical, or is it? Or is it, do we have still the, wait, this worked. Maybe we have the same bug in the reschedule here. Probably in the do timer, huh? Do we also have, we have the same CPU bug here. Schedule it always in the same CPU we have been running on, should probably be fine. So yeah, if you think this is annoying, I think so too. I'm still dreaming of my hypothetical amazing microkernel. The more you shell subscribe, the faster you build the right one. I think the APIs, even in C, could be more amazing. Maybe stuff shouldn't be C. Somehow like, yeah, but that's also why I would want, yeah, drivers like user space apps, more amazing APIs. Somehow stuff shouldn't be, even in C, shouldn't be that convoluted, but somehow it is. As always, looking for your feedback. If you agree or disagree, leave me in the comments below. Just need to read. Alright, so also obviously if you do this all day long and for profit and stuff, then you run this in a virtual machine. I mean, I run literally that other stuff in a virtual machine, right? But you could even do that, even on this aging Intel Xeon Xserve. Run this in QEMU and pass the USB device to your VM, right? And so did I post this already? So yeah, so that's the RGB swap stuff, right? Obviously the T2 logo should look like on the homepage. So it's like, yeah, I've never seen that. So that is a, I mean, maybe, also, yeah, there's some dust on my display. Maybe there are some fields for RGB in EFI. I actually don't know. Like either that is an Apple or NVIDIA bug, because it is NVIDIA graphic, or there's some API and nobody cares. A difficult question there. What do I think is the best alternative? I guess currently Rust, although I mean, Rust has many amazing properties as it has. I mean, even lightweight, I said for 20, before the invention of Rust, I said like at least use lightweight embedded C++. But, even I would say even that is better. The problems with Rust are micro dependencies, and the language is also like really, in my opinion, not the easiest to read syntax. Hey, it didn't crash yet. Yay, two out-of-bound CPU things uses for the T2. Let's see if it still reasonably works, like emerge bin utils here for T2 Linux. Also, you know what, we could like for this bash, oops, bash or... So, let's see if there is some... Yeah, I guess that looks like it works. It basically looks. I mean, I don't even need to make a video. It looks basically unchanged and reasonable. Yeah, this you could do. It looks basically unchanged and reasonable. I mean, the way to further test this is, I mean, you could print k all the load and idle values. Is this really scheduling over all CPUs? Because it's blinking like everywhere. Like, okay, let's Control Z should be. No, I think there's something not amazingly working, because even like that it blinks. Maybe there is something with this jiffies, maybe. Maybe these are too few scheduling things. That's interesting. So it's displaying something, but not useful stuff. How did I... diff null. Okay, to restore the other, okay, we could like patch reverse p1 x2. Would delete p1. Let's, and then patch that. So that was a previous working state. I probably should have tested that this actually works. So we have here a load of 0. It's blinking everything. So maybe there's a reason why Ben Herrenschmidt, like maybe because we don't have scheduled, like maybe the jiffies, maybe the wall clock jiffies, but yeah. Let's hope we can RM mod that with. That's the previous version with 1 work queue per CPU. Yeah, that works better. So there we now have 2 versions. So this looks. Do we have? At least this version appears to be somewhat. Yeah, 1 core. Yeah, that makes so much more sense. Are we still building? Yeah, that blinks so much more reasonable. Okay, so much too. Let's quickly clean this up in half an hour, only making it worse. The cool thing is, I mean, I kind of like that you see the load per CPU. That's actually pretty cool. It looks like that, right? This should be a video somewhere. Is this a video? If I would change this to accumulate the load per socket, you wouldn't like you. It's simply cool to see like where the Linux scheduler schedules the stuff to. So. You know what, I think I will not spend my time to do this differently because it's just too freaking cool. Like basically, in my opinion, like more work would make it worse. So theoretically, so that's how you would do this with 1 work queue, but somehow it doesn't work. It should probably only be probably the jiffies are way off, or maybe they are not in sync. So probably that's not how you do it. And maybe that's probably the reason why Benjamin Herrenschmidt. I mean, I do not know such details of the Linux kernel. I do this too seldomly to know such things. That's only a few. Now you would need to get into that, and basically it's not worse to spend more time making this more efficient. It still needs some more cleanup though. So that is, I had this already prepared. So that is xserve here. And so now we have, so that's my 200 lines. Oops. So makefile. You could even group it nicer, like all this stuff. So first kconfig, then makefile, then It's a new file. It still needs a little bit renaming. So that's the version that appeared to work. Alright, we also want to... obviously we want to disable the logging, and we could just do that. Package... kernel. If you're wondering what amazing Linux distribution that is of course running T2 Linux. Maybe I should send this upstream, and just to get more like into the hang of upstreaming things. Yeah, what do we do if this fails? Does this return the error, right? Stop sending. I mean, it's always easiest to draft error codes when, so maybe we don't want to build this for both. It's always easiest to draft error passes when you see an error, so like basically if there are USB errors or stuff. What is task? Was it task set? What was the freaking syntax here of display and specify CPUs in list form? Was it C1? What could we CPU burn? Okay, so this should be on CPU 0, right? Yep. So I guess that maps one-to-one to whatever sibling thread. Yeah, that's the second LED that I really could. Oh wait, 8 is already. Oh wait, did I do you? I did 0. So that should be this first and second row. Sure it is. So yeah, that works. Amazing. The future is now. Yeah. So yeah, I can confirm this tested. Of course, it's not ideal. With multiple work queues, we are sending the data after the first CPU, so the others are a quarter of a second potentially racy off. But that's the least of my concern now. It's basically illustration how to write a USB driver in 3 hours. I hope you enjoyed this and learned something, and find it as amazing as I, for all the Linux freaks out there who want to run necessities for glamorous IT living stuff infrastructure. Don't forget to subscribe, maybe Patreon, YouTube membership and stuff, right? Buy me a coffee as seen earlier. We have one more driver. So like, yeah, unfortunately it still needs some more cleaning. It's always like one more thing. I guess that's enough tested for today. And alright, we also have like, yeah, I probably best do that like on the couch at home or stuff, or on a rainy weekend. Also, Apple, no, not Apple, is MCI, Xserve. We also have to rename it from skeleton, right? So we probably have still some skeleton driver things here. So we would want to rename this all to front panel. But that's not just one SED front panel, SCAL front panel. You get the idea. And I hope to see you soon for all the next fun stuff. And if you want to try this Linux distribution, don't delay. Try T2 Linux today. Have a good one, day or night. And I hope to see you soon for all the next fun stuff to come.